Now we're going to speak with Kim Johnson, VP of Marketing for Igor. Kim is the Vice President of Marketing at Igor, an information technology and services company. Before Igor, Kim built a career in marketing and client consulting. Kim, take it away.
Wonderful. Thank you, Hampton, and thanks for having me here today. When I think of future-proofing, I think of how we can improve the value and longevity of the building. And such a huge part of it depends on the ability of the structure to be economically maintained and easily modified during its life of service. So that's why any discussion around technologies and future-proofing have to have long-term considerations. And a lot of the speakers have touched on some of that today. I'll focus on software since that's really my expertise or an area of knowledge, but really every smart building in the most simple form has an IT infrastructure, hardware, and software. So when we think about the traditional economic model of a building, you've got your big upfront costs of constructing the facility, ongoing maintenance, maybe a large renovation at some points to repurpose the structure, more maintenance, and then the building's lived its useful life. So the majority of the cost of the building actually occurs after the original structure has been completed. The promise of a smart building is to make that ownership of the building more economic, more flexible, easier to adapt. And this is possible if you make the right technology decisions. One critical piece is obviously selecting a software provider. So you are going to be looking at a lot of technology. And we've mentioned that, and that might be a theme today. You're going to be looking at a lot of technologies, a lot of software solutions, but ultimately you need an overarching IoT smart building platform to bring everything together into one manageable spot. Otherwise, you have 10 different logins for 10 different systems, and they're all different silos, and they don't talk to each other, and you don't actually have a smart building. And when you look for that overarching theme to help with that future proofing, you really want to find companies that are software as a service companies. That's most of them today, but in the building industry, sometimes this has been a little bit slower of an adaptation. Buying a software solution up front without an ongoing service, software as a service agreement, sets you up for dating your software. It's a depreciated asset then, and you don't have access to all the ongoing updates. And eventually you're going to have to, in 3 to 5 years, buy new software, update it, do a big overhaul. Instead, if you do software as a service, you're going to get those ongoing updates, which optimizes performance, consistent updates on cybersecurity, especially if you look for a SaaS software provider that puts security first as an underpinning of its solution. You're certainly going to have improvements in software maintenance, user assistance. And then if you have a good overarching platform, it's adaptable. You can integrate sometimes easily, sometimes a little more effort, but usually you can always integrate additional third-party applications as you go. For better or worse, COVID-19 has been a great example of an unforeseen event triggering new use cases for buildings. So your building management software needs to be adaptable, allow you to respond flexibly, connect everything together in a central location, a central repository for all of your data, and then that allows you to continually have an updated software solution for your building as needs change without radical changes or without having to reinstall or do huge upgrade efforts. It can be gradual, ongoing in the background. Now, of course, a SaaS model is a little different. Your CFO, your finance team, I went a little too far. Your CFO and your finance team are going to be interested because obviously now, if you're not buying the software, it's not an asset, it's an operating expense. It just hits income statements a little bit differently and needs to have that consideration. But that means that when you move from software as a service, or from purchasing software with a depreciated asset model to something that can grow, adapt, and change with your building. And this is really critically important for that smart building to be future-proofed. Now, there's also a factor of hardware. Hardware, in this case, I'm really going to be referring to things like end devices. End devices come in a lot of different formats. all of these can be smart. More of these can be smart. You can buy intelligent devices from an awesome provider out there, or you can buy standard lighting and connect it to your IoT platform, and it becomes smart. So anything that really consumes energy in your building can be a part of your intelligent building network. It can be managed, controlled, centralized in one central platform. That makes it much, much easier to operate, helps with that future proofing of your facility. And really the days of that top-down proprietary system are gone. That's a hindrance to the modern smart building. And of course, what goes in your walls is important too. And so my vision and kind of what I'm going to refer to with IoT infrastructure is really what's behind the scenes. One option I want to highlight to consider is this idea of power over Ethernet, or PoE, playing a bigger role in managing your smart building. It's a tried and true technology, a global standard, and increasingly used to power and control more and more end devices because it carries power and two-way data transmission. So for a future-proof smart building, it's critical that you choose something that's safe but flexible, adaptable, and increasingly supportive of the electrification of your facility, which is a huge push and requirement in the future of sustainability for a lot of our facilities. PoE technology is a great fit for these modern demands. And with that, Hampton, I will actually turn it back to you for any questions you might have.
No, it sounds great, Kim. Thank you so much. So with everything you were going through and what you're talking about, let's kind of go through the sustainability side just a little bit. So within this particular technology, especially as you're looking at the alternative power, how really is that going to benefit for individuals who are looking at trying to achieve those sustainability goals?
Yeah, well, and first of all, I think sustainability is a key component in your future proofing. We're seeing local jurisdictions, states, countries mandating it and looking at mandating more sustainability measures. So get ahead of the trend. And when you leverage something like power over Ethernet to connect all of your devices with one software solution to manage it, first of all, PoE reduces the use of several materials like high voltage wiring, conduit. You can actually save on material costs by using PoE, and by using less materials, you're already doing the first R that we all learned in elementary school, the reduction of the use of materials, right? So going really back to the basics, reduce the amount of materials you have in your building if you can, leverage the compatibility of data and power in one cable. And then so much of this now can be driven by choosing providers that abide by things like healthy material standards. And then when you have everything connected through the same system, like a power over Ethernet based building with a software solution, you've electrified everything. You can have a microgrid. There's trends and discussions in DC based microgrids, which is what PoE enables as a DC power transmission source. And you can manage your data. A lot of energy reporting and efficiency requires pretty specific data reporting requirements. And if you have to go into 10 different systems to figure out energy consumption, we all know what a mess that sort of data can be. So bring it together, make it easy to understand your energy consumption, leverage the smartest way to build your energy framework in your building, which is, I think, going the DC low voltage route as one way of minimizing your energy usage, minimizing your materials requirements, and then also maximizing your future ability to implement solar in your facility, which solar is natively DC also. So you can see this pattern. You can start to implement the infrastructure now, and then as you go, you can start to use those renewables, adhere to local standards. And ultimately, technology like this helps you with well building standards, lead points. There's a lot of information out there. Your providers can help you with it. And you can have an incredibly sustainable building that's also smart, that's also pretty future-proofed. And I think ultimately, that's a win for everybody.